Okay, number one, we're going to factor out the greatest common factor. Well, both of these have a y, and they're both divisible by 7. So if you pull out a 7y, you're left with 3y plus 5. Just double check before you circle your answer that there's no common factor here in that leftover. So all of these are divisible by 4, so I know I'm going to be taking out a 4. And when we look at the q's, I have 2, 1, 3. 1 is the least, so that's the greatest common factor. And when I look at the b's, we have 1, 2, and 2. 1 is the least, so I choose 1 here. Open up this, and I need to multiply by a 3q to get from here to here, plus 2b to multiply to get to there, and minus 5q squared b to multiply to get to that. And there is no common factor here, so I know that that's the final answer. The way this is written, I have two terms. This is one term separated by this. This is the other term. This is my common factor. So if I pull out the common factor of x plus 3, I'm left with this minus this. Be careful, the negative is going to distribute through there. So I'm going to be left with 4x minus 1 minus 3x plus 2. And this negative is going to distribute through, and we'll get 4x minus 1 minus 3x minus 2. And that simplifies to x minus 3. And we still have this. If somebody were to make a mistake, it would almost always be right here. They would put a plus there, when actually that turns into a minus because the negative distributes. There's a plus here, so that we don't have to worry about distributing a negative. So this is an easier problem. The common factor is z plus 1, so we factor that out. And we're left with this plus this. Z minus 4 plus 2z plus 3. And this combines to 3z minus 1. And we still have this z plus 1. When you have 4 terms, you're likely going to be factoring by grouping. So when you do this, these first two don't have anything in common, so they cannot be grouped together. So I'm going to need to reorder this. I'll reorder this and this because I can see they both have a 4. So I have 4m plus 4q. Now, between these two, I'll put this one first because it has an m. So that'll make the ordering a little nicer. Plus nq. Then I'll group these two together as if they're a separate problem. I'll factor out the 4, and I'll be left with m plus q. Now I'm going to leave a big space, and I'll put m plus q again, because whatever I leave behind here, I have to leave behind here. Then I'll think about what needs to go here so that when I distribute, I get back to those. So it looks like a positive n. Now the way this is written now, I have two terms. This is a term separated by this. Here's our common factor. So we pull out the common factor of m plus q, and we're left with 4 plus n. Now if you get yourself confused, FOIL this out and make sure you get back to the original. Your terms might be out of order after you FOIL, but they should all be there with the correct signs. For number 6, the order doesn't work because this doesn't have anything in common. So I'm going to rewrite this. I see an x here, so I'll pair this with this. So I have x squared plus 5x. I've already done those. Now between the other two, this has a coefficient of 1. This is a bigger coefficient. So I'm going to put the smaller coefficient first, then the bigger coefficient. So I'll put plus xy plus 5y. If you put these out of order, it's okay. It's just going to take you a little more difficult in the next step. So this order makes it nicer. So now I'll group these two together as if they're a separate problem by factoring out an x, and we'll be left with x plus 5. I'll leave a big space and put down x plus 5 again, because whatever I leave behind here, I have to leave behind there. Then this has to be a positive y. So now I can see that I have the x plus 5 in common, and I'm left with x plus y. Again, if you get yourself confused, FOIL that out and make sure you get back to the original. In this problem, I don't need to reorder because there's something in common here. So I'll factor out the 2, and I'll be left with m plus 3. I'm going to leave a big space and put m plus 3 down again, because whatever I leave behind here, I have to leave behind here. Then I'll think about what goes here so that when I multiply, I get to that. So it looks like a negative a. And just double check. Negative a times this is that, negative a times that is that. So it works. This is the common factor, so I factor it out. And then we're left with 2 minus a. Okay, for this problem, I don't need to reorder because there is something in common here. So I'll group those two together, and I'll factor out a 2m. That leaves behind a minus b. So I'll leave a big space, and I'll put a minus b down again, because whatever I leave behind here, I have to leave behind here. Then I'll think what needs to go here, so when I distribute, I get to that and that. It looks like a negative p. So now I can see that this is my common factor, so I factor that out. And I'm left with this minus that. There's more than one way to do these problems, but I'm going to use the slide, divide, slide. So I'm going to start by sliding the 3 over, and I'll get negative 12. I'm looking for factors that add up to negative 1. So if it's negative, 1 has to be positive and 1 has to be negative. But the bigger one has to be negative because of this middle term here. So I'll do 4 and 3. So then I'll have p plus 3 times p minus 4. But don't forget, you have to divide by what you slid over. If the fraction's reducible, just reduce it. And if it's not reducible, when it has a denominator, you have to slide that denominator back. If you feel like you're confused, FOIL it and make sure you get back to the original. So if I want to use slide, divide, slide for this, I'll start by sliding the 12 over, and we get negative 36. So because it's negative, one's got to be plus and one's got to be minus. When I add them together, I'm actually subtracting. This negative here tells me that the bigger one has to be negative. So 12 and 3 gets me to 9. Let's see, 9 and 4 get me to 5. So that's what I'm after. Negative 9 and positive 4. Those multiply to negative 36, and they add up to negative 5. So I've got r plus 4 and r minus 9. And then I'm going to divide by what I slid over, the 12. If you can reduce those fractions, you have to do that. Dividing by 4 gives me 1 over 3. Dividing by 3 gives me 3 over 4. Now that I've divided, I'm ready to slide this back. So I end up with 3r plus 1 and 4r minus 3. With big numbers like this, first check to see if there's a GCF, but there's not, so we're going to have to just use slide, divide, slide. We slide that over and get positive 300. Because it's positive, I know these signs are the same, and I know they're both positive because that's a positive and not a negative. So I know I'm adding up to get to 37, which tells me that each factor has to be smaller than 37. So how about, well, let's see. You can use a calculator, but you can start thinking of numbers like 10 and 30, but that adds up to 40. So I'm going to try, let's see. I'll just grab a calculator and I'll try something bigger than 10, like 12. And I divided by 12 and I got 25, and that's it. So I found them. Sometimes this work takes a little longer, but we have m plus 12 and m plus 25. So I'm going to divide each side by what I slid over, the 10, and I'll reduce. Dividing by 2 gives me 6 over 5. Dividing by 5 gives me 5 over 2. And then I'll slide this back, and I'm going to end up with 5m plus 6 and 2m plus 5. Don't worry about these extra variables for now. Check if there's a GCF. There's not, so we'll slide this over and we'll get positive 30. I know that because this is positive, these have to be the same, but they're both negative, not positive. But I do know that they're adding up to 11 so each one has to be smaller than 11. So hopefully you can see that it's 5 and 6. Those multiply to 30, but add up to negative 11. So now here's how I do this. I go k minus 5, and I have to throw on that h now. K minus 6h. And then I'm going to divide by what I slid over. And I'll reduce if I can. Dividing by 5, I get h over 2. Dividing by 2, I get 3h over 5. And then I'll slide this back. And I end up with 2k minus h and 5k minus 3h. Okay, there's no LCD. I'll deal with that variable later. So the first thing I'm going to do is slide that over, and we get negative 18, which tells us that one factor is positive and one is negative. This positive in the middle tells me that the bigger one has to be positive. So this has to be bigger than 4. So how about, well, let's see, 6 and 3 bring me to 3. That's not going to do it. How about 7 doesn't go in, 8 doesn't go in, 9, and 2, that gives me a 7. And there's really an 18 and 1. So this can't be done. So this is prime. A couple things on this. The first thing I'm going to do is reorder this so it goes in descending order. So I'm going to have negative 2x cubed minus 2x squared plus 24x. And now they're all divisible by 2 and they all have an x. So I'm going to factor out a negative 2x. That leaves behind a 1x squared plus an x minus a 12. Now there's no leading coefficient, so I don't need to slide, divide, slide. I'm just looking for factors of negative 12 that give me a difference of 1. It's negative, so 1 is positive and 1 is negative. The bigger one has to be positive, so 4 and 3. So my final answer is negative 2x, x plus 4, x minus 3. I don't have any coefficients or any GCF that can come out, so I multiply that over and I get negative 6. So 1 is positive, 1 is negative. This tells me that the bigger one has to be negative. So 6 and 1. That multiplies to negative 6 but adds to negative 5. So I'm almost done. Half of this is 2, so I'm going to have k squared plus 1 and k squared minus 6. That's because k squared times k squared is k to the 4th. That's my slide. Then I'm going to divide by what I slid over. This one can be reduced to 3. So this is going to end up as k squared minus 3. This one cannot be reduced, so I slide this over, and this one gives me 2k squared plus 1. Because I see this repeating element, I'm going to choose something like x is equal to p plus 2. And then what that gives me is p squared x squared plus p x squared minus 6x squared. And I can see that all of these have an x squared. So I'll factor out the x squared, and I'll be left with p squared plus p minus 6. There's no leading coefficient here, so I don't need to do slide, divide, slide. I'm just looking for factors that give me a difference of 1. So positive 3 and negative 2. So this part is p plus 3 and p minus 2. And I don't need to divide out anything because I didn't do slide, divide, slide. So instead of putting this x squared here, I'm going to put what x is. And this will be p plus 2 squared. And that's the final answer. And that's it.